guys, today we're going to be talking about exponents and order of operations, and this goes with the learning goal. I can correctly apply the order of operations with exponents. First we need to just talk about a little bit of vocabulary. So there's 3 vocabulary words we need to keep in mind when we're talking about powers or exponents. An exponent is the little number right up here when we see a number like this, and that tells us how many times to multiply the number by itself. We also have what's called a base, and the base is the big number. That's the number being multiplied. So the base tells us what number is being multiplied, and the exponent tells us how many times. And then the power is this whole thing right here. So this whole thing is called a power. So that's an expression using both a base and an exponent. So the exponent's the little number, the base is the big number, and the power is the whole thing. If I want to take a multiplication expression like the one here, where I have the same number being multiplied together over and over and over again, I can rewrite that using an exponent. Now remember from my vocabulary just before, the base is the number being multiplied together. So my big number here would be 3. And then the exponent tells me how many times I'm multiplying it together. So I have 1, 2, 3, 4, 5 3's there. So I would raise that to the 5th power. 3 to the 5th power means the same thing as 3 times 3 times 3 times 3 times 3. Now it is a very common mistake that people make, that they think that 3 to the 5th power means 3 times 5. That is not the same thing. This is not a multiplication problem saying I need to take my base times my exponent. What I actually need to do is take my base times itself, the number of times that I see in my exponent. If I want to find the area of a square that's about 1.5 meters on each side, so if I think about having a square and each side is 1.5 meters, you might remember that to find area of a rectangle or area of a square, we do base times height or length times width. So in this case, I'm going to do 1.5 times 1.5. Or I could write that using an exponent as 1.5 to the 2nd power. Now I'm going to go ahead and enter that into my calculator. So when I enter this into the calculator, I'm going to do 1.5, and then I want to do this to the 2nd power. And some of your calculators will have a button that's called a caret, that looks kind of like an arrow pointing up. And then I now need to say, well, what is my power? So I'm going to enter the power of 2 and hit equals. And I can see that 1.5 times 1.5, or 1.5 to the 2nd power, is 2.25. My unit here would be square meters, 2.25 square meters. If I want to find 3 to the 5th power, I can either multiply this out by hand, do 3 times 3 times 3 times 3 times 3 5 times, and then actually multiply that out. I could enter that multiplication problem into my calculator, or I could use my calculator again and do 3 and use my power key to the 5th power and find out that that equals 243, which is what I would have gotten if I would have multiplied that out too. So remember, we've talked about order of operations in the past. Exponents are second in our order of operations. First we do parentheses, then we do exponents, then we do multiplication and division going from left to right, and last, very last, we do addition and subtraction going from left to right. Here's an example where we have to use order of operations with exponents. So I'm going to start at the very top of my order of operations and do parentheses first. So I will do this first part inside the parentheses, the subtraction problem first, -2 to the 4th power plus, and I'm going to just be rewriting the problem as I go, 3 minus 5 is the same thing as 3 plus -5, and 3 plus -5 gives me -2. I'm going to leave those parentheses in there right now just to show that I'm taking that whole -2 to the 4th power. So I've now rewritten the 3 minus 5 part. So now I'm going to go through and I'm going to evaluate both of my exponents because that's next in my order of operations. The first one here is a -2 to the 4th power, and there are no parentheses around the -2. So what our book is going to tell us to do is they want us to take 2 to the 4th power and then make that answer negative. So I'm going to go ahead and do that on my calculator. 2 and my power key to the 4th power gives me 16. So I'm going to go ahead and say that this will be 2 to the 4th power is 16, so I'm going to make that negative 16 plus, now I'm taking negative 2 to the 4th power, so I have to see what that will do. So I'm going to do negative 2, my power key, and 4, and that is a positive 16. So I'm adding negative 16 plus positive 16, and that gives me 0. Here's another example, and again we need to follow our order of operations. So I'm going to start with parentheses. 3 plus 5 is 8 to the 2nd power minus 2. 8 to the 2nd power is the same as 8 times 8, which I know is 64. Minus 2, I do the subtraction last, and I get 62 for my answer. So like I just explained, the book says that these two things are different. What they say is that you should, in the first case with the parentheses, write negative 3 times negative 3 times negative 3 times negative 3. And if I want to enter that into my calculator, I actually do have to put those parentheses around the negative 3 in order to get it to evaluate that correctly. Because look at this. We have negative times a negative, which is going to give me a positive, and another negative times a negative, which is also going to give me a positive. So this whole answer should be positive. If I get something negative when I do this on my calculator, I'll know I didn't do it correctly. So I'm going to put parentheses, and then in this calculator I have to hit 3 and then the positive to negative button. On the blue calculators, there's actually a negative button. You would put negative 3, close parentheses, and now I'm going to do my power key, and I'm taking that to the 4th power. And I've gotten a positive answer, which I knew that I should get, so I know I got it correct. So this is going to be positive 81. Now, if I look at this other expression over here, so if I do this on one of the blue calculators, it is going to do 3 times 3 times 3 times 3, making that 3 to the 4th power, which we know is 81. And then it's going to take this negative and put it on the front and make that negative 81. So what I really want is this. What I really want to do is take negative 3 to the 4th power. I need to remember, if I'm doing this in the calculator, to enter those parentheses into the problem. Or you can just predict to yourself what your answer will be. If I added another negative 3 here, if instead of 3 to the 4th power, negative 3 to the 4th power, this was negative 3 to the 5th power, I'd be multiplying by another negative 3. And so in that case, I'd have this part still being positive, this part being positive, but then when I multiply a positive by a negative, I would end up with a negative answer. So you can predict, based on the power, whether your answer is going to be positive or negative, or you can just be careful with your parentheses when you enter it into the calculator. So here are your free response and multiple choice questions. Your free response question says, your friend says that 2 to the 3rd power is equal to 6. What did your friend do wrong? And the multiple choice question says, in the expression 2 to the 4th power times 7 minus 6 to the 3rd power, what should you do first? So go ahead and pause the video now and answer those two questions.